Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com program, brought to you by Techstrong, AWS, and Pulumi. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting presentation ahead. First, I do need to cover just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we want you to send those in to us using the Q&A tab. You can find the Q&A tab on the right side of your screen, along with a few other options. The first one you'll also see is the chat tab. We'd like you to reserve that for more general discussion, so let us know your thoughts throughout today's program, maybe from where you're joining us or what role you play in your organization. If you click that polls tab, you'll see that we do already have 5 polling questions opened and ready for you to respond. So we'd really like to get your feedback there as we want to bring that information into our presentation today. If you click the handouts tab, you'll see a version of the slides that are available for download. So feel free to grab those at your own leisure. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our program. So our topic today is getting started with infrastructure as code on AWS. And I'm joined by Scott Lowe, Principal Technical Content Engineer at Pulumi, and Marina Novikova, Partner Solutions Architect at AWS. So Scott, Marina, thank you both for joining me today. Marina, would you like to get us started?
Yeah, thank you, Cody, for introduction. Good morning, good afternoon. It depends where you're located. Thank you so for joining. As Cody introduced it, Marina Novik, I'm a Senior Partner Solution Architect at AWS. What does it mean is I work on the partner technical aspects of like relationship with the ISVs like Pulumi. Super excited because I look at startups and there's like smaller companies, which is typically has extremely nice new super cool technologies. We built a new capabilities integrations for AWS users and customers. So today I'll be happy to dive a little bit. I'm pretty sure you're familiar with infrastructure as a code. We'll cover what it is and why, right? But I wanted to talk a little broadly about everything as a code concept and why it's important in the nowadays in the reality when we wanted to do cloud native applications. So let's talk a little bit about like evolution, right? And along with evolution of the application software architecture, there is evolution of the infrastructure and the tools we use to run it, like how we develop and deploy. And there's evolution of the roles as well, as like we came from traditional DevOps as a separate team, and now it's all like super collaborative and merged in with our developer company developer teams. So originally, many years ago, 40 plus, when the organization like started out, life was very simple, right? It was a single server concept and design. The entire application stack and the helper application database were deployed to this single server. Management was simple, and if you needed to install something or needed to troubleshoot, it's like you just log into the server. Due to flaws of this design, architecture started to decoupling components, start to like decoupling database, for example. They naturally went to their own server when it came to client server application. With the internet errors, like we have a like user interface, move it to the browser and they have web application, right? So what actually it led us is that admin teams grew and pretty soon there is a few fleet of the people managing the operating system patches, the database patches, the application deployment, and so on. So job roles got like much more redefined. Infrastructure and applications started to become so complex. You needed individuals who specialized in these areas to keep things running, performing well. This is how DevOps teams appears, right? Then you will see the shift move towards using commodity hardware and build up redundancy horizontally. And we come to the service oriented architecture and microservices. So instead of trying to build robust hardware which can consolidate and run all of our services, we see multiple different like components and like different servers. And to make sure it's a scalable and redundant, and we protect it, and we can run like it for multiple users. So the idea was to think about service as a fungible component that you expect might fail. Application design also changed as one had to think about sessions and data persistence. So the shift launched a rapid expansion with a number of the servers. And we see that the tools started to pop up on the market as monitoring system, login systems, firewall management system, patching system, and let's going on and on. So, but fast forward today is when we complexity of a modern application is growing and engineering team is seek to increase bit of agility for by breaking complex system and and the amount of the server should grow, right? To remove this constraint, the company start to migrate to the cloud to get the benefits of their spinning up any infrastructure when they need and where they need. There's a lot of benefits in the cloud, but the old approach to our DevOps concept and the tools do not work that well on the cloud anymore. And we need to learn and we need to understand how to build the processes inside of the cloud to be able to spin up infrastructure a new way. And this is where infrastructure as a code come in extremely handy and helpful. So let's dive into this what kind of benefits it's coming and why, and what is everything as a code as a concept, and what kind of practices are there, and why version control system becoming so important and becoming the single source of the truth to ensure the management of the distributed system in a scalable, consistent, predictable way. So as I mentioned, it is like the code repository will look at the source of the single source of the truth. Just step back and summarize it is like where we are and what happened. So if you imagine as an older data center, you would need to new server to spec out, right? And you need to project as of the growth of the application usage for 5 years. For example, you need to purchase that server, you need to install in a data server in specific rack, and run server install, you need someone to install operating system, application dependencies, is join it to network, add backups and restore, monitoring application, etc. Even with virtual machines, it didn't become easier task. It just allowed you to use a different hardware. So now with a cloud native thinking and approach in AWS, I can define all these components as in different files and launch them in the minutes around the world, around the globe, in any AWS region. So it's very pretty much mind blowing how we came up from the months to the minutes. So what really makes it happening, possible? It's basically everything is a code. If you're looking at the everything is a code as define it as an idea of codifying all aspects of the software development, including the infrastructure, including schemas, pipelines, configuration, basically anything that is associated with a cloud should be codified. So that gives us a lot of benefits. For example, what I mentioned earlier, develop a deployment in the minutes around the globe in any region. It consistent and predictable. So having everything codefined, remove the variability that often gets introduced by the human error in human deployments. It's a communication. If you look at the code, it's not only a way to deploy or tell computers what to do, it's also a form of documentation and communication between team members in teams. Code is reusable. I can move code from one project to another and offer up something codified as a template or blueprint for other teams to contribute, and set up a standard practices across a different teams organization. And lastly, code is easier to test and validate compared to the physical components. So let's dive just a little bit more, in each of the aspect different mentioned it already, or I wanted to bring up a lot of different aspect where you have to think code is first, as everything as a code implementation side of team. So let's start from infrastructure as a code as a topic of our conversation today. It's the most common type of the collaboration outside of application code and software. To quickly level set, infrastructure as a code is a way to treat infrastructure the same way as application. are treated. With the Pulumi, it's becoming even easier because you can use any language of your choice, favorite languages, and you don't really need to learn if you're not familiar with YAML or something else. Infrastructure is defined as declarative way, stored in the source code repository system. For starters, infrastructure should be in the, treated as immutable. So we cannot really think old school when there's like I was logging in it as a server and changing something like manually, right? Ideally, once deployed, there should be no attempt to alter configuration or resources such as deployment patches or manual configuration. The next one is environment as a code, is abstraction over infrastructure as a code that provides a declarative way of defining the entire environment. Think of environments such as development, testing, staging, or production environment you have typically in like your team. An environment should be include all these components necessary to stand up an entire environment. It's not only compute resources or application code and services, but also everything such as the DNS, networking, firewall, load balancers. And it all has to come from different teams all together to have not only your specific service deployed there, but all as a part of the platform if you have a multi-service application. All of the edge cases, the traditional environment are already set up for us. So just think, if it's I'm developer, I typically use only 40 hours for my application, right? And deployment or development or testing. I don't need really to run it for 7 days a week. It's 168 hours per week. So basically, you can schedule the environment running only specific hours and have a like cost saving for your organization as well. The same as for testing your environment, you can spin up when it's needed. You say it can spin up only you need a sandbox, or even you say like this, it's for disaster recovery if your production environment went down. The next one very important is like and very highly popular right now is a GitOps concept. If you know the company Waveworks originally coined it back in the days as operating model for Kubernetes and other cloud native technologies, which provides set of the pricing that the unifying both deployment management and monitoring for clusters, Kubernetes clusters and applications. Another way to put it is a path forward or towards developer experience for managing application, not only writing application code, where end-to-end CI and CD pipelines and Git workflows apply to both operations and development. And you think about it, GitOps is a concept can be exposed beyond and like expanded beyond Kubernetes. It can be applicable to Lambdas and serverless. It can be applied to other infrastructure. You can look at the Git as a single source of truth for everything, for more than just infrastructure, but also for configuration, DevSecOps, policies, everything you want to define in files and be like repeatable across different environments. So configuration is a code treats configuration just an application code as well. The next one is coming to the policies code, if you're familiar with that. And pieces can be in two different aspects. That one is typically known as an open policy agent in the CI/CD implementation for the user action. So I wanted to control who has access to which environment, to which one infrastructure, and which one team can do what. But also policy code, if you think about that, it can be guardrails as a mechanism we use in Amazon to as a processes that reduce the occurrence in the blast radius of undesirable application behavior. The typical example will be the public S3 bucket or long-living access secret keys pairs. Guardrails are both proactive and reactive, but fully automated. And you can get familiar, for example, with a Pulumi cross guard. We even ran a workshop last year in December, and you can find the documentation and get like some of these policies implemented as is in your team. So just to summarize, is where like basically like everything is a quote looking to like bringing us and like looking to achieve, right? So one of the biggest problem for multiple years it was a consistency of doing everything by hand was bringing a lot of like error, the simple error in the sequence of executing the like steps how to implement something or type can bring it like a big issue. Such issues happen at more frequently than we admit it to happen. which means in a large infrastructure and over time, each server, each router has to be configured the same way. So when using infrastructure as a code, when your infrastructure is declared in a code and applied consistently to any number of the targets, you have guaranteed consistency, which means there is a single source of the truth, your code. You don't need to go and to ask your team, like John, Doe, Beth, what was applied to specific server or to specific like what like version was deployed. You can always look at the code and the traceability inside of your tools and implementation. What is the result of that is a less amount of the risk. We minimize the risk. And although the risk still can be eliminated completely, and we still need to bring additional DevSecOps practices like application securities, vulnerability scanning, and so on, you have clear visibility to what happened and when, and you have clearly defined status across the range of the times that help you test, roll back, and audit. But what about who's writing the code? Was there previously done changes by hand? Well, now they can easily collaborate. I can share my ideas easily, can share my code. I can get peer reviews and feedback for my infrastructure, and can leverage the work of my peers more effectively, even become capable of more easily distributed and complex and large project across distributed systems with a more governance at place. All the above results in what? Efficiency. Things happen faster, safer, and the overhead and managing the infrastructure is reduced, regardless of the scale of the infrastructure being managed. That's a pretty beautiful. So I really encourage you to implement everything as a code practices, keep your infrastructure immutable, and move across repeatable infrastructure. Scott, I think after that, I'm happy to handle it to you.
All right, great. Thank you, Marina. I appreciate that. I apologize, folks, that my camera is not on. I had a camera crash while Marina was giving her presentation. So we're going to have to just stick with audio and slides. And most importantly, I have a live demo to show you all as well, which you all can follow along with if you want to follow along as part of the demo. So building on what Marina was sharing about infrastructure as code and everything is code, I want to just provide people with an on-ramp on how you can get started with infrastructure as code on AWS using Pulumi. So I do work at Pulumi. I'm part of the developer relations team, and it's my job to help folks be successful with Pulumi. So as far as participation throughout the remainder of the webinar, you're welcome to follow along during the demo. In the next slide or so, I will provide a list of all the things that you need. Feel free to provide comments in the chat, ask questions in the Q&A. If you want to continue to interact with us or continue along your journey with Pulumi, you can join our Slack instance. Just go to slack.pulumi.com, and that'll let you sign up for an account. We're always open, and we welcome your feedback on anything, this workshop or this webinar, or anything else. So we would love to hear from you if you have something to share with us. So now thinking about the demo, what you want to do if you want to follow along is you'll need to install the Pulumi CLI, and you can visit our website, pulumi.com/docs/get-started/install. As you can see on the screen there, for a link on installing. If you're a Mac OS user, you can simply use Homebrew and install with a brew install Pulumi. And we do provide an ARM64, aka Apple Silicon binary that run natively on the new Macs. You'll need a free account on the Pulumi service, which I'll talk about in just a moment, and that'll help provide state and secrets management, among other things. Obviously, we're going to be using AWS here, so you'll need an AWS account. And to ensure that everything is configured correctly, we indicate that you really want a working installation of the AWS CLI. We don't rely on the AWS CLI, but that just helps ensure that all of your secrets and authentications and et cetera, are appropriately configured. And because we're going to be walking through using TypeScript in today's webinar, you'll want to make sure you have Node.js installed and working. So I'll let folks work on those prerequisites while we kind of set things up a little bit and talk about the Pulumi service. So the Pulumi SaaS service offers, among other things, state and secrets management. So when you run a Pulumi deployment, your state of what was created will be stored in our SaaS service. There is a free tier that offers unlimited deployments for individuals. It supports any language, any cloud that Pulumi supports. So even though we are using TypeScript today, you could easily use Python or anything of that nature. I see a question popped up in the chat about a specific version of Node.js. Something relatively recent. If you're on an Apple Silicon Mac, I think you really need to look at Node.js 16 for a native build. I believe we support Node 12 or later, but 12 is getting a little old, so I would recommend probably a newer LTS version. I generally use Node 16. So there's a bit.ly link here that you can sign up for a free account, and you can create an account by linking it to GitHub, GitLab, Atlassian, or you can just sign up with your email. And then once you sign up there, then you'll be able to sign in using the Pulumi CLI. And then when you run up a Pulumi deployment, it will store all of your state for you. And if you do leverage any secrets, then you'll be able to have the secrets stored securely there as well. Again, free account, free for individuals with unlimited deployments supported. Now, you might be asking the question, okay, why infrastructure as code with Pulumi? Well, building on all of the benefits that Marina talked about earlier in terms of consistency and repeatability, and being able to leverage things like immutable infrastructure, and having a single source of truth, and looking at things like storing your infrastructure as code artifacts in a source or a version control repository like Git. That has a whole number of benefits in and of itself, but we believe that using Pulumi to do infrastructure as code lets you do a number of things, right? It lets you really harness the modern cloud. You're going to be working with modern tools. You're going to be using general purpose programming languages. That's going to bring what you're doing for cloud infrastructure closer to application development, allow you to leverage all of the investments that your development team is using in terms of IDEs or code editors or linting, integration testing, unit testing, et cetera, mocking, so on and so forth, right? Basically, we're enabling you to apply software engineering practices to your infrastructure in order to tame complexity and, again, leverage the same tools. And that enables, we believe, innovation and collaboration faster across the entire team, which is why we believe Pulumi offers real advantages for users who are embracing infrastructure as code with Pulumi. All right. So what I'd like to do now is let's get out of the slides. Let's go to the live demo. Again, if you want to follow along, you're more than welcome to do so. All you need is the Pulumi CLI installed, which you can do with Brew if you're on Mac OS. You need a working AWS CLI installation to verify that your credentials are configured correctly. We'll leverage those credentials with the Pulumi CLI. Obviously, you'll need an AWS account as well. And because we're using TypeScript, you'll use Node.js. And you'll want to sign up for the Pulumi service and get yourself a free account. So I'm going to switch over to my screen here, and we're just in a terminal because we're going to be doing that from the terminal. And I'm in a directory. Actually need to get out of this directory. Here we go. Let's switch tabs. There we go. Okay. And so I'm in a directory that I've created. This is where I'm going to create my new project. And you'll see if I list the files, there's really only one thing here. It's an environment file that sets some environment variables. This is not necessary. This is just something specific to my particular system. Okay. And in here is where we're going to create our first Pulumi project, right? And I'll just point out, Marina posted the link for signing up for a free Pulumi account in the chat. Thank you, Marina. Appreciate that. So feel free to go grab your free account there. But we're going to create our first Pulumi project here. And to do that, we're going to use the CLI, and we're just going to say Pulumi new. And what this is going to do is it's going to give you a list of, oh, I forgot, I got to do force. Because I have a file here, it says, wait a minute, there's files here. I don't want to do anything. I know it's okay. It's not going to overwrite my file, so I just need to put an F here. All right, it's going to give me a list of all of the different options I can use to bootstrap my new Pulumi project, right? And you can see there's a ton here. We support lots of languages, lots of providers. And if you look down towards the bottom of the screen there, you'll see the beginning of our AWS templates. So, we're going to be working out of TypeScript. You can see it's already scrolled off past here. So I could, type AWS TypeScript, and you'll see there's a number of templates that have AWS type in them, right? But if I were to select one of these and press enter, then it's going to go through and get us started with our first project. Now, in this particular case, what I'd like to do is I would like to create a Pulumi program, and I'm going to go over some of the terminology that I'm using here, projects and programs and templates. But I would like to create a Pulumi program that allows me to deploy an EKS cluster, a Kubernetes cluster on AWS. And so I see I have a template here named Kubernetes AWS TypeScript, right? So, and the description, you see it's a TypeScript program to deploy a Kubernetes cluster on AWS. So I'll just press enter there. By the way, if you know the name of the TypeScript, you can just put it right after the name of the template, excuse me. You can just put it right after the Pulumi new command. So if you know you just want like a basic starter program that doesn't do anything, just gets you the scaffolding, right? You could say Pulumi new AWS-TypeScript, and it'll give you a very, very basic, scaffolding for a TypeScript program that'll stand you up on AWS. Alternately, you can browse through the list of templates like I did and select one to get you going. Now, this is the new project wizard. It's going to walk us through some questions. It's going to ask us for the project name, and it's going to supply a default value. If you just press enter, it's going to accept that default value. And in this case, it's taking the name of the directory EKS cluster, which I'm fine with. A description, okay, it's a TypeScript program. I'm good with that. What is the name of the stack? I'm going to explain stacks in just a moment, but I'll just accept the default name of dev. And now what region do I want to deploy into? I'm going to deploy into US West 2. How many nodes? What instance type do I want to use? What's my maximum size in terms of auto scaling the cluster? What's the minimum size? And what network CIDR do I want to use for the new VPC? And then it's going to go through and install some Node.js packages via NPM that are necessary for the program to run. And this only takes a couple of minutes, generally speaking. And now you see that it's ready to go, and we could run Pulumi up. Now, before we do that, though, I want to talk about some of these terms that I've been using. So I'm going to flip back to the slides real quick. And let's talk about Pulumi's model and talk about some of the terminology. So we organize things that you're going to do into projects. And you saw me in that term, we use a directory as a project. So a project is really just a directory that has the files that are necessary to support a Pulumi program. And then a Pulumi program is the code using whatever language that you prefer to use, whether it be TypeScript or JavaScript or Python or Golang, or one of the .NET languages like C# or F# or Visual Basic.NET, or even a JVM-based language like Java or Scala. That's the program that will leverage the Pulumi libraries and SDKs to then interact with the cloud provider like AWS. So we have the idea of a project, right, which is a directory that has the files necessary to run Pulumi in it. We have the program, which are going to be the files that are going to be used by whatever language runtime that we're going to use. And that will vary from language to language, right? But what about this thing, template? Well, a template is just a starting point for your program. It's basically some boilerplate, some scaffolding that you can use with the Pulumi new command to get you going. So you're not starting from absolute zero ground floor, right? Instead, we'll give you some scaffolding that'll get you started. And we have templates that are very, very basic. We also have some templates that are more advanced, like the one that I'm using in this webinar, which is the Kubernetes on AWS template. So a template is what's used with Pulumi new, and it will walk you through the new project wizard, which will set up your project, and it'll give you some boilerplate to go into your program. Your program will create a series of resources. These are going to be things that are existing on the cloud provider, right? In the case of what we're talking about today, we're going to be creating, VPCs and subnets and all kinds of other things, right? Each of these resources is going to have a series of inputs and a series of outputs. Inputs are things that get passed into the resource to configure what it is Pulumi is going to do to create that resource. An example would be passing in the CIDR range for a VPC as an input, right? Telling the Pulumi program, this is the network address range that I want to use for the new VPC that I'm going to create. An output would be, for example, the ID of the VPC that gets created, right? After it's created, that would be an output that we can then go and use elsewhere. Now, you can exchange inputs and outputs between resources, and it's very, very common. We'll see in just a moment as I show you the program that the template that I just ran created to take outputs from one resource and use them as inputs in another resource. And this is how we create dependencies between these two things. For example, we need a VPC before we can create the EKS cluster. So we will take the VPC's ID as an output, and we'll use that as an input to our EKS cluster. Stacks are individual instances of a program with its own configuration. Now, you saw me as I walked through the new template wizard. It asked me some questions. What network range do you want to use? How many nodes do you want? What instance type do you want? All that becomes part of the stack configuration. Now, if I wanted to run this exact same program again with a different set of parameters, I could do that. And I could just create another stack. And then that stack would have its own configuration and then could go manage its own resources, right? So a stack is going to be a program plus its configuration, which is going to manage some resources on a cloud provider. All right, so now that we have that terminology sort of in place, we can come back to the terminal again. All right, and so here we are in our terminal, and I'll show you a few things as you walk through here. And again, remember, you could be doing all of this as well if you went back and got your dependencies sorted, right? With the Pulumi CLI installed, a free account on the Pulumi service, an AWS account, working configuration of AWS CLI, and Node.js because we are using TypeScript. So at the top of the screen here, you can see this is the new project wizard. This sets some configuration values. And so if I just list the directory now and show you the files that are in here that make up this project, right? Remember that a project is a directory that has all the files necessary for the Pulumi program to run. Then we see that the new template wizard has populated a number of different files here for us. So we have some TypeScript and Node.js necessary files like package.json, tsconfig.json because we're using TypeScript. We have the node module subdirectory, which has all of the various modules that we installed to be used by our TypeScript program. Our actual TypeScript program is found in the index.ts file. And then we have two YAML files. One is pulumi.yaml, which is the project configuration. So, whoops. Okay, there we go. And you can see that this contains information that was also prompted by the new project wizard, the name of the project and the description. The runtime is Node.js because we selected TypeScript. And then we also have a pulumi.dev.yaml. Now that pulumi.dev.yaml is our stack configuration. And you can see here, it has all the information that we prompted through the new project wizard. So it has our region, has the desired cluster size, the instance type, all that kind of jazz, right? And I can run Pulumi stack ls, and you'll see that I have only a single stack, and that's why I only have that single pulumi.dev.yaml file. So the new project wizard has dropped us out. It has asked us for all these configuration values that it knows the program needs, right? If I wanted to manage two different EKS clusters in two different regions, for example, I could have two different stacks, one pointing to US West 1 and one pointing to US West 2 or US East 2 or whatever you wanted, right? Or overseas, EU West 1, as well as different instance types, different cluster sizes, different network CIDRs. Now let's take a look at the actual program that it wrote for us. And to do that, I'm just going to display the index.ts file. And we'll look through that real quick. So this is all generated automatically by the new template wizard or the new project wizard. And it's all determined by the template that we selected. So in this case, I ran one of our architecture templates, the Kubernetes on AWS using TypeScript, and all of this came out of that template. So all of this scaffolding and boilerplate is created automatically for you when you run Pulumi new. And so it imports the necessary libraries or modules to the top, sets some configuration values by reading these values in. And this is what it's reading in, what we just saw when I ran the Pulumi config command, right? Pulling those values into the program to be used elsewhere. And then you can see it creates a new VPC. It creates the EKS cluster. I'll draw your attention to sort of this line right here, where you can see the example of us using an output from one resource as an input to another resource. We're taking the VPC ID that was created when we created the VPC, and we're now saying, okay, when you create the EKS cluster, it's going to go in that VPC we just created, right? or it's going to go into these public subnets, or it's going to go into these private subnets, for example, right? Here's where you can see it bringing in some instance type information, right? This is where it's using some of the configuration values that we gave it when we ran the new project wizard. By the way, you can also change those configuration values at any time using the Pulumi config set command. And just set, it's a key value pair. So you set the name of the value, and then you set, or they set the name of the key, and then you set the value. And then as we move down through this program, you'll see that we export some values. Notably, notice we're going to export something called a kube config. And this will allow us to actually access the cluster that ends up getting created by Pulumi. So I saw this question pop in terms of AWS. Pulumi is more like AWS CDK rather than CloudFormation. In terms of AWS, yes. Key difference here is that CDK will end up generating CloudFormation on the back end, and we will actually execute whatever language you're writing in natively, and our core engine will then build a declarative resource model based on that code and then manage the infrastructure declaratively based on the code that you wrote. No problem, Marina. Glad to help out. So this is an example of the program. Now, this program takes a little bit to run. So rather than us running it and then sitting around looking at it while it runs for about 15 minutes or so, I've actually taken the liberty of running something early and letting it complete, and then we can kind of see what that happens. And it's the exact same program, exact same template. I just stored it in a different directory, so it would be considered a different project by Pulumi. But let's flip over to my other window here. And if I just list this, then you can see, you know, exact same set of files that we saw earlier. And if I expose that index.ts here, then you can see it looks exactly like the other program, right? They were both created using the same Pulumi new command. I just put them in two different directories so that I could run one in advance and show you what it looks like after it's done. In the meantime, if you are following along and you want to go ahead and run, then here is where you would go ahead and run your Pulumi up command. And when you do that, it will run the code that you've written using the language runtime. The engine will take the output of that program, create a declarative model of the resources that need to be created. And then it will tell you, this is what I'm going to do. And so you see in this case, it's going to create approximately 60 resources. And that's going to be a VPC, subnets, route tables, internet gateways, NAT gateways, et cetera, security groups, blah, blah, blah. All of the necessary infrastructure, and then the EKS cluster and all the components that are needed by or for the EKS cluster. All right. Now, again, this takes a little bit to run. Feel free to go ahead and run it if you're following along, and it will run, and just give it some time. But in the meantime, while we wait for folks to go ahead and run that, if they wish to do so, I want to go ahead and explore this this stack, this project, this identical project that has already run. And so I have already run Pulumi up on here. And if I run Pulumi up again, what it will do is it will go out and it will say, well, what's out there already and what do I need to do to anything? And you'll see that in this case, it says, I don't need to do anything. I've already run this. So you can see this is an example of the fact that this is a declarative model, right? I'm writing in an imperative language like TypeScript or Go or Python, but the engine actually runs and manages the resources declaratively. All right. Let's see. I'm just commenting here. Breakout of Pulumi to stack creation would have been helpful. I can show you how to create a new stack if that's what you're asking about. So we'll look at that in just a moment. And then you can go from there. Writing templates is a little more complex. So if you're interested in learning how to write a template, come find me in the Pulumi Slack, the Pulumi community Slack. I'll have a link for it towards the end of the presentation, and I'm happy to show you how that works. But now that this is run, I can actually say, well, show me what the output of the stack was. And you can see that the output of the stack is a couple of different things. The VPC ID down here at the bottom, right, which shows me the VPC ID that was created. And then all of this is the kube config that is used to access the cluster. Now, I've already pulled this down by using Pulumi stack output kubeconfig. And that command just says, give me the specific output called kubeconfig from the stack output, right? And I've saved that locally so that I can run it using with kubectl. And you'll notice my prompt here, even in fact, shows you that it already shows an active Kubernetes context here. And so I have an alias for kubectl. A lot of people use K. I use KC. Doesn't mean I'm a Kansas City fan. Doesn't mean I'm not a Kansas City fan, but that's a different story. And if I just run a KC get nodes, then you'll see that I have the 3 nodes that I configured this for, which again, we can confirm using Pulumi config, and we see desired cluster size, minimum cluster size set to 3. So again, just sort of a reiteration that the program is doing exactly what you told it to do. And it has created the cluster per the configuration values that you have provided in the program that you wrote, that the template started for you, right? And obviously I could run additional kubectl commands, but I mean, the fact is that it's there, right? The list of all the pods. Okay, there you go. So yeah, we could deploy an application to this if we wanted to. We could, in fact, write another Pulumi program, create a new Pulumi project, and actually take the output, the kubeconfig output from this project, and consume it in the other project to deploy applications declaratively to Kubernetes using Pulumi. And that is a very common sort of way of doing things for customers, is to use Pulumi, a Pulumi project or stack or set of stacks to stand up, basic infrastructure, VPCs, subnets, that kind of stuff, and then consume the output of those stacks in higher level stacks that build on top of that to create ECS clusters or EKS clusters, or EC2 instances, or databases, whatever the case may be. All right, so you've seen how this works. Now there was a comment in the chat there, and again, folks, feel free to ask questions via Q&A or put stuff in the chat. Awesome that a participant got their new stack up and running. That's fantastic. Super cool to hear that. And but feel free to ask questions or post in the chat. We'd love to hear from you as we work through this. And Marina adding some additional color there about differences between CDK and CloudFormation and Pulumi, that sort of thing. So thank you for that, Marina. Appreciate it. Now, there was a comment in the chat about creating a new stack, right? And so I could walk everyone through doing that real quick. It's really not a difficult process. Now, remember that a stack is just an additional instance of the same program. So a template creates an entirely new program and new project, all right? But a stack takes the same program and lets us pass different parameters to it. So here in this directory, this is the one where I've already run Pulumi up. I'll do a Pulumi stack ls and show you that only one stack exists, and it's called a stack called US East 2. And I'm kind of silly about that. I create my stacks to match the region where I'm deploying. That way I can look at a stack and always know what region it's in. And then I'll differentiate it, via additional things. If I have a US East 1 or US East 2 prod, US East 2 dev, something like that. But it just makes it easy for me to see where things are. And I can see the current configuration for this stack. Notice that the stack has a little asterisk behind it. That means it's the selected or active stack. And I can see the current configuration just by doing a Pulumi config. And it shows me everything that I need. If I wanted to create a new stack, I can just do a Pulumi stack init. In other words, I want to initialize a new stack here, right? And so it'll walk me through a little bit of a wizard. I'll say, okay, you're going to create a new stack. What do you want to call this? Well, let's call it EU West 1, okay? Now, notice it doesn't prompt me for all the values. That's something that only the new project wizard does. And so here I have to use Pulumi config set to actually set the values that I need. So we'll do a Pulumi config set AWS region to EU West 1. And then we'll set our VPC network. I hope so I type it correctly. VPC network CIDR. Okay. And we'll set our desired cluster size. And then our EKS node instance type. All right, and then min cluster size as 3 and max cluster size. Okay, and so now if I do a Pulumi config, then we'll see these values here. We have the region, which is a required value. If you try and run a Pulumi up without the region set, it'll throw an error because it doesn't know where you want to deploy your resources. And now if I do a Pulumi up here, then it's going to go out and it's going to interrogate AWS, communicating directly with AWS APIs. It's going to say, this is what I need to create. And notice it now says, oh, wait a minute, I have 60 things to create. Now I'm going to say no here, and I'm going to switch to the different stack. I'm sorry, I have a US East 2 here. Put me up again, just to show you that these are different instances of this program running with different configuration values. And you see here, if I go back to the US East 2 stack, which has already been instantiated, it's already been created, then it knows, declaratively speaking, I don't need to create, I don't need to do anything. Everything that you've asked me to do is done. It's all there. I don't need to make any changes. But if I switch stacks to a stack that has not been created, it's not had Pulumi up run on it, then it says, well, now I have things that I need to create. And so this is how you could leverage multiple instances of the same program within the same project, right? To perhaps deploy infrastructure to different regions, for different environments, for different users, whatever the case may be, okay? All right, so let's switch back to the slides real quick. Now we've talked about the model and we kind of went over that and we went back to our demo. So I want to just provide, and a lot of these resources, I think Marina's already linked in the chat, but I'll make sure we just talk about them real quick here. We have a lot more Pulumi tutorials available on our website at learn.pulumi.com. And this will take you through a series of basic procedures, help you understand more about stacks and programs and projects, how to do what we call stack references, which is taking outputs from one stack as inputs to another stack, for example, among other things. Just basically walk you through how to do some very cool things with Pulumi, including being able to use your favorite programming language to create additional abstractions to make it easier to create stuff with Pulumi, right? There's plenty of examples on how to use Pulumi. We have a GitHub repository available under the Pulumi organization called examples, and there's probably 200 plus examples in there of different cloud providers, including AWS, different languages, and different resources or environments that are being created. I would also encourage you to take a look at our full getting started documents at pulumi.com/docs/get-started. And yes, I will switch back over to the terminal and show you the last few commands that I ran. You can also look at the code and see where it's using the config library to see what commands it's looking for, what configuration values it's looking for. The getting started docs also take you through creating a project and a program and a stack. And we'll do that for all the major providers, including AWS. And then we have lots more resources linked at pulumi.com/resources. So links to additional workshops that we've conducted and they're recorded that you can look at, links to our YouTube channel where we talk about infrastructure as code and all of that sort of thing that are all available on there. Now, let me flip back over to the terminal. I know some folks wanted to see some of those commands. So let's see, there we go. So here's some of the commands that I ran to create a new stack. We started with stack init. We set the configuration values. Now, keep in mind, these configuration values will change from program to program. So these are the configuration values for this particular program created by our Pulumi template, right? The best way to know what configuration values are needed is to look at the code itself. So if I look at index.ts, and you'll notice that these lines at the top where we talk about config get number, this is where it's reading in configuration values. So this is the value name that it's looking for. And if you don't supply it, then in TypeScript syntax, that means if this isn't defined, then I will default to 3. So a lot of those you can get away with not defining in this particular program because we've supplied default values for you. Some programs will not have default values, so just keep that in mind. All right, let me bring that back up again. There you go. All right, feel free to take a screenshot or whatever you need. I would just clarify, configs aren't bound to templates. the templates provide boilerplate or scaffolding for the program. The program defines the configs, right? In this case, the template generates a lot of code for us. And so all the configs are there. In other cases, when you use a more of a starter template, it won't define as many configuration values for you. So the code is what defines the configs. And that's what you'll need to use to your config commands to set there. So great questions. Thanks for all the Q&A there. All right, so that's the end of the content that I had. That leaves us some time for Q&A. Looks like there are some questions in the Q&A channel there, and also time for the giveaways, which I'm sure you're all very interested in. Let's try to answer this question here real quick. Question is possibly outside the scope of the demo, but how sensitive is the state file or the storage? If others make changes to deployment external, how involved is the process to correct that in the Pulumi program? So the state file itself is just a record of what it did, what the program did when it was executed, right? So these are the things that I created or that I destroyed or that I modified and their current state, right? If you have information that is marked as secret, then that information gets encrypted, but the state file otherwise is not encrypted and generally is not considered sort of sensitive. There are mechanisms in Pulumi for you to mark an output as secret, to mark inputs as secret, that sort of thing. And in which case, then we will encrypt that data so that it cannot be viewed just in plain text, right? If somebody makes changes to deployment, then the next time you run a Pulumi up, it will check to see what's there, and then it will show those corrections in the list of changes it's going to make, right? So you saw when I ran Pulumi up, it went out and basically interrogated the cloud provider to say, what's out there right now? What's the current state of what's out there right now? And what do I need to do to make what's out there right now match the state as defined in the program that you supplied to me? So usually there are rare cases where you might have to do something more than that, but usually another Pulumi up will just bring those configuration drift items back in line. Next question, and then I'll pass it back to Cody to do the giveaways. Or actually, it looks like Marina's answering that right now, but she'll answer that. But the answer is yes, you can configure it to use different entities, and that's usually handled through your AWS CLI configuration. Okay, so that's it for me, Cody. Back to you.
Awesome. Thank you, Scott. And thank you to Marina for joining us as well, and keeping all those questions that were coming into our chat, keeping them answered and making sure that our audience actually got some information that they wanted to get out of today. So really appreciate all the time that went into putting together these presentations and the demo as well, Scott. So thank you so much. And I also do want to thank everyone for filling out our polls today. If you have not had a chance to look at those up till this point, please do fill those out. Our Pulumi and AWS would really like that information for their feedback. So our session today was recorded. Should you want to watch it, you should receive an email with a link to access the recording on demand, or you can find it living on the DevOps website at devops.com/webinars. Scott did mention we have 4 $25 Amazon gift cards to give out. So our winners are Kelly B, Eric M, Nathan S, and Ramon C. So to our 4 winners, congratulations. Keep an eye on your inbox to claim that gift card, but if you don't happen to see an email, please do check your spam folder. I'd like to thank AWS and Pulumi for sponsoring today's program. And to everyone who's been with us for the last hour, thank you so much for joining us. We really, really value your time, and we also value your feedback. So as soon as we close out, there will be a survey that will pop up on your screen. Tell us what you liked about our program. Tell us what you'd like to see on future programs, or just anything else you'd like to say. Otherwise, we do hope to see everyone at an upcoming Techstrong Learning program. Have a great rest of your day, and Scott, Marina, thank you once more.